Section 10.4, Example 2, Bogart. Our second game will be a two-player dice game. In Bulls and Cows, one of our players was human, and the other was the computer. This time we'll write a game for two human players. Randomness again will play a key role. Once we're done, you can play against a friend or family member. Section 10.4.1, How the game works. The game that we'll be writing here is called Bogart, and was designed by Crab Fragment Labs. This is a dice game for two players. The game also uses a pot of chips or coins. We obviously won't need actual dice or chips, though, as we're implementing this as a computer game. Bogart. The Bogart game was designed by James Ernest. Copyright 1999 James Ernest and Cheap-Ass Games used by permission, crabfragmentlabs.com. You can download the instructions for the original game for free as part of a PDF file of games. See this link. If you enjoy the game and can't stop playing our recreation, we encourage you to support the work that Crab Fragment Labs is doing. We thank them for letting us use their game here. When the game starts, the pot of chips is empty, has no chips in it. One of the two players is randomly chosen to start the game. From there, each player takes turns until the game is over. We'll first explain what it means for a player to take a turn, and then give the rules for when the game ends. Figure 10.5 provides an overview of the flow of the game as well. At the beginning of a player's turn, one chip gets added to the pot, and that player rolls one die. If that die is a 1, then the player's turn is over, and they don't collect any chips. If that die isn't a 1, then the player gets to decide whether to continue their turn or not. If they decide not to continue their turn, they collect all the chips from the pot, making the pot empty.
Figure 10.5. Player turn in Bogart.
If they do decide to continue their turn, then 2 chips get added to the pot, and they roll 2 dice. If one or both of those dice is a 1, then the player's turn is over. Otherwise, the player again gets to decide whether to continue their turn or not. If they continue their turn, then they roll 3 dice, then 4 dice, and then 5 dice. Players can't choose to skip a number of dice. They must work through the number of dice sequentially starting from 1 die. If they ever roll a 1, then their turn ends, and they don't collect any chips. If they decide not to continue their turn, then they collect all the chips from the pot. Rolling a 1 in this game is bad news for the current player. When rolling 1 die, the probability of rolling a 1 is low, only 1 in 6, about 17%. When rolling 2 dice, the probability of rolling at least 1 1 is higher, this time about 31%. It's higher still when rolling 3 dice, 42%, 4 dice, 52%, or 5 dice, 60%. So, the longer you extend your turn, the higher the probability that you'll eventually roll a 1 and get nothing for your turn. Worse, you'll likely leave the pot quite full for the other player to collect if they play more conservatively than you. At the same time, the longer you extend your turn, the faster the chips in the pot accumulate, and the more chips you can collect assuming that you do successfully end your turn eventually. The whole trick is to decide when to press your luck for more chips, and when to take what you've got. This is how a player's turn works. Players alternate turns, rolling dice and collecting chips, until the game ends. There are 2 ways that the game can end. 1. If a player collects a total of 30 or more chips, then that player wins. 2. Say a player on their turn rolls 1 die, then 2 dice, then 3, then 4, and then 5, never once rolling a 1. Then that player instantly wins. It doesn't matter how many chips they've collected. If they get to 5 dice of which none are a 1, they win. Example game of Bogart. Let's play out a few turns of the game to make sure we're clear on how it all works. The pot starts out empty. Let's say that player 1 is the player randomly chosen to go first. We add 1 chip to the pot, and player 1 rolls 1 die. Let's say that they roll a 5. Now player 1 has to decide whether to end their turn and take the 1 chip from the pot, or continue their turn. Let's say that they continue their turn. We add 2 chips to the pot. Now the pot has 3 chips. Player 1 rolls 2 dice. Let's say they roll a 4 and a 2. Should they end their turn and take the 3 chips? Nah. They want more. They continue their turn. We add 3 chips to the pot. Now the pot has 6 chips. Player 1 rolls 3 dice. This time, they roll a 6, a 5, and oh no, a 1. Player 1's turn is over. They got no chips, and they left a juicy 6 chips in the pot for player 2. Now it's player 2's turn. We add 1 chip to the pot. That's 7 chips now. And player 2 rolls 1 die. Let's say that they roll a 2. If player 2 ends their turn now, they'll collect the 7 chips from the pot. That feels like a lot, so let's say that player 2 does decide to end their turn. Now the pot is empty, and it's back to being player 1's turn. Player 1 has some catching up to do. They have 0 chips, and player 2 has 7 chips. We'll stop here, but the game will continue until one of the players racks up 30 or more chips, or they get to roll 5 dice and manage not to roll a single one. Section 10.4.2 Top-Down Design. As was the case when we implemented our Bulls and Cows game, implementing Bogart is a large problem for which we need top-down design. We'll offer that design now, but here we encourage you to try it on your own before continuing. We recommend this because we found an effective top-down design to be subtle for this game due to the number of interacting elements. For example, a player's turn can end in one of 3 ways: collect the chips, don't collect the chips, and instantly win. We need to be able to determine which of these situations happened. As another example, after each player's turn, we need to switch to the other player. Except, unfortunately, not always. If a player wins the game, we want to stop the game right there and declare them the winner, not switch to the other player. We'll primarily focus on our successful top-down design here, but we'll occasionally justify why we made our decisions and what went wrong with other decisions. We'll name our top-level function play. Here are the main subtasks that we'll need to solve for our game. 1. Initialize the pot and start player 1 and player 2 with 0 chips. This is part of the game's setup phase. 2. Randomly choose player 1 or player 2 to start the game. This too is part of the game setup. 3. Now we enter the gameplay phase. While the game isn't over, do the following. A. Print the number of chips in the pot, number of chips player 1 has, and number of chips player 2 has. B. Take a full turn for the current player. C. If the current player won chips, give the chips to the current player, and reset the pot to have 0 chips. D. Switch to the other player's turn. 4. Print the name of the player, player 1 or player 2, who won the game. At this point in the book, we suspect you've become familiar enough with the code from Copilot to have some nice intuition about which of these tasks will require separate functions. Task 1 is just a few variable assignments, so we don't need a separate function for that. Other tasks for which we don't need a separate function are Task 2, just a call to random.randint, 3a, just a few print calls, and 4, a print call. We'll capture each of the remaining subtasks in a function. The following subsections describe each of the remaining subtasks. Task 3, while the game isn't over. We'll have a while loop that continues while the game isn't over, so we'll need a function to tell us whether the game is over. How can the function know whether the game is over? It'll need to know the current number of chips that player 1 has and the current number of chips that player 2 has. That way, it can check whether one of these is at least 30. But remember that there's another way for the game to end, and that's when a player rolls 5 dice, none of which is a 1. Therefore, this function will also need to know the most recent dice rolls for the current player. We'll name this function Game Over. It will take 3 parameters: player 1 chips, player 2 chips, and list of rolls. It will return true if the game is over and false otherwise. The code for this function will need to check a few conditions, but we should be able to do that without splitting it out into further subtasks. Task 3b, take a full turn for the current player. We'll name this function Take Full Turn. The function needs to know how many chips are in the pot right now, so that it can update that as needed. It'll also need to return the updated number of chips in the pot. Beyond that, there's a lot that we need to manage to carry out a full turn, so we're going to need to keep the complexity of this function under control. Here's what comes to mind for what this function may need to do. 1. Allow the player to roll 1 die, then 2 dice, then 3 dice, and so on until the player's turn is over. 2. Update the current player's number of chips based on what happened on this turn. We could add an additional return value to communicate this updated information to whoever called this function. 3. Determine whether the game is over. We could add an additional return value where true means that the game is over, and false means that it isn't. We initially tried to have the function do all 3 of these things, but were unable to receive satisfactory code from Copilot. This isn't too surprising because we're asking the function to do too much. This led us to focus on the core of this function, which is point 1. But okay, if we focus only on point 1, then how are we going to update the current player's number of chips? Point 2. And how will we know whether the game is over? Point 3. For point 2, the solution we thought of is to not update the current player's chip count at all in this function, instead returning the total number of chips in the pot after this turn. For example, if there were 10 chips in the pot and this player's turn generated 6 chips, then we'd return 16. The player may or may not get to collect these 16 chips. It depends on how their turn ended. But we won't deal with that here. This is for the calling function to manage now. For point 3, knowing whether the game is over, our solution is to have the function return the most recent list of rolls as part of its return value. This list of rolls will also be needed by the calling function for point 2. The function that calls this one can then use those rolls to determine whether the game is over. In summary, our function will take the number of chips in the pot as a parameter, and will return a list of 2 values: the new number of chips in the pot after the player's turn, and the most recent list of rolls. To take a full turn, we'll need to be able to roll dice. First 1 die, then 2 dice, then 3 dice, and so on. We'll split this out into a function named roll dice. It will take the number of dice to roll as a parameter and will return a list of rolls. For example, if we ask the function to roll 3 dice, we might get back 614. We'll also need to be able to determine whether the turn is over based on the most recent list of rolls. If the player rolled any ones or rolled 5 dice, none of which is a 1, then the turn is over. We'll split that out too into a function named turnover. It will take the list of rolls as a parameter and will return true if the turn is over, and false if not. If the turn isn't over, then we'll need to ask the player whether they want to continue their turn. We'll ask for a yes, Y, or no, N, response. We can do that using a call to the input function. If the player wants to keep going, we can again call roll dice. We don't need a separate function for asking for user input, so we won't break this part down any further. If we wanted to validate the user's input, rejecting any response that's not Y or N, that would increase the complexity enough so that we'd probably split it out. In summary, we've split out 2 subtasks for our take full turn function: roll dice and turn over. These functions don't need to be broken down any further. For roll dice, we can use random.random in a loop to generate the rolls that we need. And turnover will amount to a couple of checks on the dice rolls to determine whether they ended the turn, for which we won't need any further breaking down. Task 3C. If the current player won chips, when a player's turn ends, we're furnished with the new number of chips in the pot and the final list of rolls that ended the turn. We need to determine whether the player gets those chips or not. If the final list of rolls doesn't contain a 1, then the player collects the chips. Otherwise they don't, and the chips stay in the pot. We'll split out a function to tell us whether the player collects the chips or not. We'll name it wins chips. This function will take the most recent list of rolls as a parameter and will return true if the player wins the chips and false otherwise. Task 3D. Switch to the other player's turn. We'll name this function switchPlayer. Suppose that the current player has just finished their turn. We need to switch to the other player's turn, but only if the game isn't over yet. Our function will encapsulate this logic. It will need to call game over to determine whether the game is over, so we need at least 3 parameters for switchPlayer: player 1's chips, player 2's chips, and the most recent list of dice rolls. We'll also need a parameter to indicate the current player, 1 or 2, so that we can return the number of the new current player. So, the function will take those 4 parameters, and it will return a 1 or a 2 indicating the player that we're switching to next. If the game is over, this function won't do anything, and if the game isn't over, then we'll need to change a 1 to a 2 or a 2 to a 1. We already have the game over function, and that's sufficient for breaking down this function. We've finished our top-down design. Check out Figure 10.6 for our tree of functions.
Figure 10.6. Top-down design for the Bogart game.
Section 10.4.3. Implementing our functions. Now it's time to work with Copilot to write the code for each of our functions. As always, we'll start with leaf functions and move our way up, left in the diagram, implementing our top-level play function only when all other functions have been implemented. We can start with any leaf function. We'll start with the game over function because it's needed both by play and by switchPlayer. Then, we'll move on to other functions. Game over. This function takes 3 parameters: the number of chips that player 1 has, the number of chips that player 2 has, and the most recent list of rolls. It returns true if the game is over, and false if not, as shown in the following listing.
Listing 10.6. Game over function in Bogart.
Remember that there are 3 ways for the game to be over. Player 1 has at least 30 chips, player 2 has at least 30 chips, or a player managed to roll 5 dice on their last turn without rolling a 1, returning a Boolean directly. You may have expected to see the code this way, with the use of if, else, and actual return true and return false lines.
See this code?
This would work, but it's more common to see programmers use a return statement directly with the true or false expression. It works because the result of the expression is what is being returned. If the expression is true, true gets returned, and if the expression is false, false gets returned. That's exactly the same thing that the if-else version does. Roll dice. This is the function that rolls our dice and adds randomness to our game. It takes the number of dice to roll as a parameter, and it returns the list of dice rolls. We'll expect Copilot to make use of random.random here, as shown in listing 10.7. In addition to returning the list of rolls, it's also helpful if this function prints each dice roll. That way, the player can see exactly what they rolled. In the docstring, we ask Copilot to print the rolls, in addition to returning the list of rolls.
Listing 10.7, roll dice function in Bogart.
Turnover. This function takes the most recent list of rolls and uses that to determine whether the current player's turn is over or not. It returns true if the turn is over, and false if not, as shown in the following listing.
Listing 10.8, turnover function in Bogart.
There are 2 ways for the player's turn to be over. The first is when there's a 1 in the list of rolls. The second is when the player has rolled 5 dice. Is len of rolls double equals 5 really enough for the turn to be over? Don't we have to check whether there were any ones rolled? No. If the player rolls 5 dice, then their turn is over no matter what, regardless of what the dice rolls were. If they rolled any 1s, then the turn is over because they rolled a 1, and they won't collect any chips. If they didn't roll any 1s, then the turn is still over, and they'll win the game automatically in this case. Take full turn. We're ready for take full turn now, as shown in listing 10.9. This function takes the number of chips currently in the pot as a parameter. It will process all the rolls from a full turn for the current player, and then returns a list of 2 values, the new number of chips in the pot and the final list of rolls.
Listing 10.9, take full turn function in Bogart.
Wins chips. This function takes a list of rolls as a parameter. If the rolls are good, that is, contain no 1s, then the player will collect the chips. If the rolls contain any 1s, then the player won't collect the chips. This function returns true if the player gets to collect the chips, and false otherwise, as shown in the following listing.
Listing 10.10, wins chips function in Bogart.
Switch player. This function takes 4 parameters: the number of chips that player 1 has, the number of chips that player 2 has, the most recent list of rolls, rolled by the current player, and the number of the current player. If the game isn't over, this function returns the number of the other player. If the game is over, then the function returns the current player, because there's no turn for the other player. See the following listing.
Listing 10.11, switch player function in Bogart.
Play. We've made it all the way up to our play function. We've decided to write this function without any parameters. You might wonder if we could make the code more flexible by adding, say, a parameter for the number of chips required to win, currently 30. You could certainly do that. We haven't done that here to keep the number of parameters smaller throughout the code. This function doesn't return anything. Instead, it plays the game, as shown in the following listing.
Listing 10.12, play function in Bogart.
We now have all the code that we need for the game. Just add.
See this code?
Below all of your existing code to call our play function, and then you'll be able to play. Customizing the game. We're happy with what Copilot has given us, and the game is certainly playable. But, admittedly, the interaction with the players could be a little more user-friendly. For example, here's how the game might start when we run it and press Y a few times. Pot chips, 0. Player 1 chips, 0. Player 2 chips, 0. Player 2 turn. 4. Continue, yes or no? Yes. 5. 2. Continue, yes or no? Yes. 3, 1, 4. Pot chips 6. Player 1 chips 0. Player 2 chips 0. Player 1 turn. 2. Continue? Yes or no? There's no welcome message. Numbers like 4, 5, 2, and so on are just there, with no context of what they mean. The game asks us whether we want to continue, yes or no. Continue what though? It isn't clear. We can make the interaction with the players more pleasant by spicing up the print calls in our functions. We can just put what we want in each print statement ourselves. Why not just use Copilot? It's likely easier to just do it rather than trying to cajole Copilot to print exactly what we want. For example, the following listing shows a new version of Play where we've added more print calls to explain what's going on and to better format the game output.
Listing 10.13. Play function in Bogart with better formatting.
We encourage you to add print calls elsewhere as well to make the game interaction even better. For example, in Roll Dice, you could add a print call to tell the players that dice are about to be rolled, rolls in the following output. In Take Full Turn, you could add a print call to print the number of chips in the pot prior to asking the player whether they'd like to continue their turn. Here's what an interaction with our game looks like after we made those changes. Welcome to Bogart. Pot chips, 0. Player 1 chips, 0. Player 2 chips, 0. Player 2 turn. Rolls. 2. The pot currently has 1 chips. Continue turn, yes or no? Yes. Rolls. 6. 3. The pot currently has 3 chips. Continue turn, yes or no? Yes. Rolls. 1. 1. 6. Pot chips, 6. Player 1 chips, 0. Player 2 chips, 0. Player 1 turn. Rolls. 5. The pot currently has 7 chips. Continue turn, yes or no? Try making such changes to your code as well. Make the game yours. In this chapter, we used Copilot to help us write 2 computer games. A logic game, similar to Wordle but with numbers, and a 2-player dice game. We were able to do this using the skills we've honed throughout the book, including problem decomposition, writing clear doc strings, and interacting with Copilot chat.